So good morning students. So in this part of the lecture, we are going to understand a method that is called as the vacuum dewatering. So let us understand first what is a vacuum concrete. See, vacuum concrete means it is a kind of concrete where the water is removed by the vacuum pressure after the placement of the concrete structural member. And if you see this vacuum concrete, this has got the high strength and high durability when you compare to the normal concrete. So we'll understand what are the aspects that governs the strength and durability of the concrete. So we all know very well that what is very important for the concrete is water cement ratio, right? So water cement ratio is very important for the concrete. So but we always, what we do, we go for restricting this water cement ratio in order to get the high strength. So in order to get the highest strength, what we do, we go for restricting the water cement ratio. So if you want the chemical reaction of the cement to happen with water, then the water cement ratio should be less than 0.38. But in the practicality, if you see, the adopted water cement ratio is more than this 0.38 because we have to satisfy the requirements of the workability. So apart from the strength, workability is also very important for the concrete, because only when the workability is there, you can place the concrete in the formwork easily without any honeycombing. So in order to satisfy the requirements of workability, you are adding more water. So what happens? This excess water will eventually, it gets evaporated and leaving that capillary pores in the concrete. So because of that capillary pores, it results in high permeability and also the less strength in the concrete. So we can always say the two requirements, that is the workability and high strength, they always don't go together, as their requirements are always, it is contradictory to each other. So that is where like this vacuum concrete plays the role. So this vacuum concrete is nothing but an effective technique which is used to overcome the contradiction of the opposite requirements of workability and the high strength. So with this technique, both are possible at the same time. That is, workability as well as the high strength can be achieved in the vacuum concrete. So what we do in this technique is the excess water after the placement and the compaction of the concrete is sucked out with the help of the vacuum pumps. So this method or this technique is effectively used in industrial floors, parking lots and the deck slabs of the bridges. And talking about the magnitude of the vacuum, the magnitude of the applied vacuum is about 0.08 MPa, and here the water content gets reduced by up to 20 to 25%. And the reduction is effective only up to a depth of 100 to 150 mm. So we'll see what is this technique and what are the equipments which are required for this vacuum concreting. So the main aim of this technique is to extract that extra water from the concrete surface by using this vacuum dewatering technique. So in the vacuum concrete, we go for removing or extracting the extra water by using this vacuum dewatering. So as a result of dewatering, you can see there is an effective reduction in the water cement ratio, and also the performance of the concrete also improves drastically. So this improvement is more on the surface where it is required the most. So basically there are four components which are involved in this vacuum dewatering of the concrete. The first one is the vacuum pump, the second one is the water separator, and the third one is the filtering pad, and the fourth one is the screed board vibrators. So we'll see the arrangement of this vacuum dewatering process in the next slide. So here you can see the clear picture of this vacuum dewatering process. So it has got a vacuum pump here, and this is the water separator, and here you can see this is the concrete surface, and on the top of the concrete surface you have this sort of the filtering pads, and on the top of this filtering pad you have this watertight backing seat, and at the end of the filtering pad you can see it is sealed with the rubber. So the rubber seal is there at the end of the filtering pad, and this filtering pad will have this sort of this wire gauges or the muslin cloth. So we'll get into the details of this arrangement in the next slide. So here this vacuum pump, as you have seen in the previous slide, this is actually, it is a small but it is a strong pump which is having the capacity around 5 to 10 HP, that is 5 to 10 horsepower. So here the water is extracted by the vacuum and then it is stored in the water separator. So previously you have seen a water separator there, and the mats are then generally they are placed over the fine filter pads which prevents the removal of the cement with the water. So in the previous figure you can see this is the vacuum pump, so which is of 5 to 10 horsepower, and here you can see the water separator for collecting the water, and this is the filtering pad which is placed over the concrete, where like on the top you have this watertight backing sheet, so which prevents the removal of the cement with the water. So here there is a proper control on the magnitude of the water that is removed, so that whatever the magnitude of the water that is removed, that is equal to the contraction in the total volume of the concrete. So here about 3% reduction in the concrete layer depth takes place. So as I told, the filtering pad consists of the top rigid backing sheet. It will have some expanded metal, or it could be a wire gauge or the muslin cloth sheet. And the rubber seal is also fitted around this filtering pad, and this filtering pad should have the minimum dimension of around 90 centimeters by 60 centimeters. And we'll see what are the advantages of the vacuum dewatering. So you can see this the vacuum pump, and here you can see here the water is stored in the water separator which is extracted by the vacuum pump, and this is the filtering pad where at the end you can see the rubber seals, and this the minimum dimension of this filtering pad, it should be 90 by 60 centimeters. Now we'll see what is the advantages of vacuum dewatering. So this is due to the dewatering through the vacuum, we can satisfy both the requirements, that is workability as well as the high strength. Number two, there is a reduction in the water cement ratio, so which increases the compressive strength by around 10 to 15%, and also it lowers the permeability. And number three, it enhances the wear resistance of the concrete surface, and the surface which is obtained after the vacuum dewatering is plain and smooth because of the reduced shrinkage, and also the former can be removed early and the surface can be put for the early use. So this clearly explains the advantages of the vacuum dewatering process. And here in this graph also you can see the advantages of this vacuum concrete over the ordinary concrete. So the advantages of the dewatering is more prominent on the top layer when it is compared to the bottom layer. So the effect beyond the depth of 150 mm is negligible. So here in this today's lecture I've explained about what is vacuum concreting and what is that vacuum dewatering method, what is the arrangement of vacuum dewatering, what are the components in it, and we have also discussed about what are the advantages of the vacuum dewatering process.